uh, and and everybody is fit to go this morning. This webinar continues the theme that we started with a decarbonisation of transport webinar, and this time we've moved on to housing. It's important from the first point of view that house energy consumption in Barbados, a third of the electricity that's generated actually goes to the housing stock, and that energy use doesn't take into account any energy that's used in construction work or energy which is consumed in the materials that are built into the buildings. So this is a major issue. Anything that can be done to make energy use in housing more efficient in the country is very important. So we're going to look at what makes housing more sustainable. I've got to apologize for the fact that you've got me as the chair of the session. My colleagues at BTPS told me that if I wanted to have a webinar on this theme, I had to chair it. So I'm afraid you're going to have to put up with me being here and acting as chair. The format is going to be that we're going to have presentations from the speakers, and then we will take questions, which I hope you can submit through the chat box, and I'll put to all of the speakers before we sum up at the end and finish. So it's a fairly simple format, and we're going to get on with it fairly quickly. It's my job to introduce the speakers, and in doing so, I want to apologize first of all that Tony Hoyos is not with us this morning to talk about the HOPE project. Unfortunately, something cropped up in his diary, and he's not able to attend, and at short notice he wasn't able to help us by providing a substitute. We're hoping that we might be able to do something in terms of visit to one or more of the HOPE sites and cover the particular aspects of that which are relevant to this topic, which is different from the other speakers because it's more about the use of renewable energy in developing a funding model which helps people to get into owner occupation. So that's a particular area which I think we would like to come back to. Having said that, I must say that we've got three very interesting speakers for you today. I've had a sneak preview of their presentations, and they certainly fit the bill. I came to this topic in a fairly naive way. And I was saying things like, would passive house work in the tropics? I now discover that we've got people who are capable of delivering passive house here. And as further background, I discovered that in Australia, they've actually applied passive house to 8 different climatic areas. So there is a scope for the passive house approach, which fits different climatic criteria. So what we have are presentations which are going to cover the principles around sustainability and design, and a number of examples. And the 3 speakers are Neil Hutchinson from Studio Blue, Asli Timur, and Gavin Cumberbatch from Argo Development Studios. And I'm going to give you a little bit of background on each of them before asking them to speak. Starting with Neil, he's the managing director at Studio Blue. Chartered architect, registered in Barbados and the UK, and 23 years experience in the profession in design, detailing, project management and implementation of projects in the UK, Barbados and the wider Caribbean. He has a degree in architecture and a diploma, postgraduate diploma in architecture with distinction from the University of Plymouth, which is quite interesting to me because I actually come from Cornwall, which is just down the road to the west of Plymouth. So I might talk to him about whether he ventured across the Tamar at any time. Neil is one of the founding directors of Studio Blue, and he's been responsible for the design of a wide cross-section of projects in the luxury residential, commercial, industrial, and institutional sectors. He's actually been involved in promoting architecture with sustainable energy for a number of years, and an active promoter of the issues. He's also, interestingly, he's won a NIFCA photographic competition, so he has wider interests than purely working as an architect. So we're looking forward to his presentation shortly. Our second speaker is Asli Timur from Argo Development Studios. She actually graduated, first of all, from the University of Izmir, and she has in architecture, and she has further degree, a master's qualification from the University of Milan. She specialized at first in acoustics designs for universities, congress halls, cultural centers, and open air theaters. And she's worked in Turkey and Japan in the past. Her MSc was in building and architectural engineering at Milan. And throughout this degree, she focused on sustainability. And she then did work on lighting design, daylighting, solar aspects of buildings, energy efficient buildings, climate resilience, sustainable built environments, and acoustic design for offices, banks, and restaurants. Currently, she is the Sustainable Energy Architect with Argo, and she leads their Climate Intelligence Unit. She provides services for design projects in the Caribbean, Ireland, and the USA. Argo is an international practice, and her specific focus is on energy modeling, climate data analysis, daylighting, solar radiation, and wind simulations for facade and built environment design. Also, she has LEED accreditation, that's Leadership in Energy and Environmental Design. That's something which, certainly for public projects in the UK, is very often a requirement in the brief. So she's going to be telling us a lot from her experience and knowledge of work across the world and in the Caribbean. And our third speaker, who is also from Argo Development Studio, is Gavin Cumberbatch, who is another Barbadian, educated at Harrison College, and then he studied architecture at Yale University in the United States, where he got a BA in architecture before returning to Barbados. And he has in Barbados worked for a number of local firms on custom residential work, luxury developments, projects at Royal Westmoreland, Casuarina Beach Hotel, Sapphire Condominiums, Lion Castle Polo Estate, and the townhouses. So he has a wide range of experience, including a period when he ran his own practice. And he is now with Argo Development Studio as studio leader for their Barbados office, and working on projects not just in Barbados, but elsewhere in the Caribbean, particularly at the moment in St. Vincent, I think. Currently, he's working on
I ain't got none on the camera. I don't know if I can use this.
Flow's headquarters and design of St. James Medical School campus in St. Vincent, and ongoing work at Apes Hill and a number of local residential projects. I think he's very enthusiastic about his role in an international practice, particularly contributing to issues around architectural design and sustainability. So those are our three speakers this morning, and without any further delay, I would like to hand over to Neil, who is going to give the first presentation.
Sorry, good morning. Is everybody hearing me now? I think I was on mute. Yeah. So thank you to the Tongue Client Society for inviting me to speak here this morning. This is a topic which I'm very passionate about and have been for some time. So without further ado, I'm going to dive straight into our presentation. So I'm going to kind of kick off the discussion in trying to touch on some of the general concepts. And so what are we looking at today? I want to start with some definitions. We throw about these terms, but we want to kind of put them into perspective. So decarbonization, passive house, sustainable design, what do these things mean? I will then dive into an overview of the concepts and issues to achieve green housing. I will also briefly look at historic solutions and current problems. And then I will have a brief look at a case study of a house that we've done that has some green aspects to it that you can sort of see exactly what we're talking about. So what is decarbonisation? Carbonisation refers to the removal of carbon from the environment. In the case of housing, homeowners can reduce energy use and reliance on fossil fuels and choose building materials that require either low amounts of carbon emissions to manufacture and transport, or actively sequester carbon by storing carbon that is drawn from the atmosphere. And I mean, on the little diagram here on the right is just putting it into perspective. So you've got, you know, vehicles, buildings, factories, animals, all generating carbon and putting it into the environment. And one of the few things that's kind of taking it out and sequestering it is actually trees. So there's a little hint there in terms of what we could be doing, how we could be tackling some of the situation. What is passive house? Passive house is a voluntary standard for energy efficiency in a building, which reduces the building's ecological footprint. It results in ultra low energy buildings that require little energy for space heating or cooling. So in our climate, obviously, we're not too worried about the heating aspect. Well, we definitely want to avoid that. But you know, in colder climates, you might be looking at and here to some extent, what type of insulation can you use? How can you orientate your building? Which is definitely relevant to us here. Balanced ventilation with the design aspects. You know, maybe high performance windows to reduce heat gain. All of these are sort of things that passive house design would look into. What is sustainable architecture design? This is defined as a design which meets the needs of current generations without compromising the ability of future generations to meet their own needs. So how are we going to be using the resources right now that we still, you know, we're not using them all up, or we're not compromising future generations and being able to do what they need to do just as we have. So to make Barbados housing greener, I think we need to tackle the following. We need to consider the microclimate and landscape. We need to look at water use and conservation. We need to tackle wastewater reduction and treatment. We need to look at or consider embodied energy and sustainable materials. And last but not least, we need to look at our energy use, or energy conservation and generation. So I'm a very visual person, so I've dropped a couple of slides in here to kind of give you a visual of what we're talking about. So microclimate and landscape, we're talking about the spaces around the building, front gardens, back gardens, you know, the spaces outside of the actual building itself will have an impact on how much energy you're using in the building and how much energy the building uses. So whether that space is softly landscaped or hardscaped, all of that stuff will impact on the energy that the building consumes or needs to consume. Water use and conservation. I'm not going to dive into this too much today, but just suffice to say that obviously if we're harvesting rainwater, we're using that for whatever purposes, whether it's flushing toilets, irrigation, washing cars, that's going to be reducing the water that we're pulling from the Barbados Water Authority's grid. And that water doesn't get to us by magic. They use a lot of energy to pump it through the mains to us. So therefore, the less water that we're using will mean the less energy that's being used on a national scale. So that has an impact in that way. Wastewater reduction and treatment. So depending on how we're dealing with our sewage and our wastewater, again, that takes energy, whether it is being treated at the South Coast Sewage Project or the Bridgeground Sewage Project, or in larger developments that have sewage treatment plants. If we can reduce the amount of sewage that we are generating and producing, that will mean the energy that we're using to treat that wastewater is reduced. Obviously, there are other environmental impacts on our island or drinking water, on our coastal environment, if we can reduce and treat our wastewater. Sustainable materials, embodied energy and sustainable materials. So where do the materials that we use come from, and what energy has gone into making those materials? Energy conservation. I like to think that if we can start with reducing the amount of energy that we use first, before looking at how we're going to put some PVs on the roof to generate the energy that we need, that will mean that the energy that we will be using will be less, and therefore the PV system or the wind turbines or whatever that we're looking at can be that much less and use less resources. One of the biggest users of energy in housing in Barbados and the Caribbean is typically air conditioning. So if we can look at natural ventilation, how the building is designed to maximize airflow through the building, to make the space habitable and cool and comfortable, then we'll be a long way towards reducing what energy we're using. There are many ways to skin a cat, so to speak. And one way, I am very passionate about the landscape and landscaping and how that interacts with the building that I'm designing. And trees and planting have a big role to play in shading buildings, shading spaces, and contributing to that microclimate. The space immediately around the climate, immediately around your building, and how you can control that to make that cooler and therefore reduce the need for air conditioning and fans and all those type of things which use a lot of energy. Once we've done all of those things, then yes, we can look at how we can generate our energy in a sustainable manner, whether it's photovoltaics, wind turbines, solar hot water heaters. A lot of these are becoming much more mainstream than they were obviously 20, 30 years ago. So how do we, just to focus in on the energy then in our buildings, how do we reduce the energy required by our housing? I've touched on microclimate and landscape. I'll expand on these in a minute. Natural ventilation and daylighting, solar heat gain and shading devices, and embodied energy and sustainable materials. So microclimate and landscape. Most projects, but not most projects, all projects when we will start with some sort of analysis of the site. So we want to, the first obvious thing is to identify where north is. That's going to then give us some sort of indication as to where the sun is rising or where the sun is setting. And something to understand, I mean, in Barbados and the Caribbean, our sun path, and that's what we're trying to identify and understand really, is generally during the summer months, the sun is going to be going much more overhead, but not really sort of north of overhead, very slightly. In the winter months, the sun will be a little bit lower in the horizon, not quite as low as this diagram suggests. This is probably more for some sort of North American location. But what that means is that predominantly the east, south, and west elevations of our buildings will be getting much more solar exposure, or when I say that, I mean exposure to sun, than the northern elevation. So that leads us then to start to think about the building in different ways. We also want to identify where's the wind coming from, because that's what we're trying to get through our building in natural ventilation. That's generally coming from the east direction or east-northeast direction. So that's going to drive us in terms of how we orientate spaces and organize spaces within the building. What's the topography, the slope of the land, and how does this impact on maybe siting of the building or buildings? And how does that impact on the wind flow? Or, I mean, if for example, if you're on a site maybe on the western side of Barbados, which is sloping facing the west, then your building may be looking west, but you're trying to get the breeze from the opposite direction. So all of these are things that you need to understand to be able to tackle these issues. Are there any existing landscaping features, trees, waters, pond, which you can use to your advantage for shading, for cooling? And all of these things will then drive the organization of the site and exactly where you want to put the building on this site. I mean, ponds, if an example, this little site analysis here, if you were to, the breeze was coming from this direction and you had a pond here and you located your building here, then you'd be getting, the breeze would be being pre-cooled, so to speak, coming over the water surface. Natural ventilation and daylighting, touched on those a little bit. It's very important to understand that you're not going to get any breeze flowing through the space if you've only got an opening on one side. So it's very important to think about where your openings are, that you have openings on both sides so you can get cross ventilation. What's important as well is where those openings are located. So if it's low down or high up, that's going to drive where the breeze is actually flowing. And the idea is to really to get air movement across the body where you're going to be located. So if the space is predominantly used in a sitting room, TV room. Can you guys maybe mute who are not obviously presenting? The other things you can look at then are daylighting. If we can get natural daylighting, we can reduce the need for electrical lighting and therefore energy use. And also in conjunction with that, we need to look at how do we get that daylighting into the space without the associated direct sunlight, because that's going to be bringing heat into the space. So something like this instance where a skylight, that may not be as suitable for Barbados unless this is some super insulated skylight, because the associated heat coming in with the sunlight will be not positive, will not be helpful. Solar heat gain and shading devices. So just to expand on this, something that seems really quite prevalent in Barbados and lots of people love to do is first thing they build the house and then they concrete the whole yard around the house. Now that's causing a big issue because the sun is shining on that surface. That surface is heating up and storing the heat, but it's also reflecting the heat and the sunlight back onto the building. So these walls of the building are getting double exposure. Not only are they getting the direct sunlight, but they're also getting a reflected light off of these hard surfaces, whether they're concrete, asphalt, tiled, whatever. And then this surface, if it's concrete or asphalt particularly, will store that heat and be radiating it later in the day, quite well after the sun has gone down. So these spaces, doing this is a big no-no in my books, because that's really generating lots of heat that we don't want to make the whole microclimate, the space around the building, because if the breeze is coming from this direction, that's going to be blowing this hot air into your building. So a much better solution would be planting, which is not going to be reflecting the heat onto the building, using bodies of water to pre-cool the breeze. These are all sorts of things that would be much more preferred. How can we control the sun radiation and heat gain? Again, we talked about trees shading the building. We're talking about, you can use overhanging eaves to protect, again, the walls, the main walls of the building from receiving the direct sun's radiation. Pergolas, patios, louvers, brise soleils, anything like that has a positive impact on keeping the building cool. Traditionally, I mean, this is a little house we did years ago, but this is a very traditional type of Barbadian house, where you might have had a wraparound patio on 3 or multiple sides of the building. You can see that this is shading the main walls of the house. They're not being allowed to be hit by the sun and heat up and store that heat. You've got overhanging eaves, you've got shutters, you've got hoods, pergolas, all sorts of things, all tools in our toolbox that architects would use to ensure that the building is cool and kept cool and comfortable. Other ways of tackling it are using the building form. So maybe you may have projecting sections or sliding screens. In this instance, we had these sort of timber louver sliding screens on the patios that we could pull across and create shade in different areas. And again, in this design, you can see that we're thinking about trees and planting and shading to create, control that microclimate. And the other thing that in you're seeing overhanging eaves up here again, which will help with that situation. But again, something that's not used enough in Barbados is insulation, particularly in roof spaces, whether it is a rock wool type or what's much more affordable and quite easy to install is what they call the R foil, which is this type of thing, which looks like foil with bubble wrap attached to it, and that works really well and is very affordable. I like this slide here because it really kind of puts it into perspective. The cooling effect of a mature tree transpiring 450 liters per day from its leaves has been estimated to be equivalent to 5 average size room air conditioners running 20 hours a day. Once this plant, so if you move on to a site that's already got a tree, then you're winning. You're already in the right direction, because this has got a huge cost, obviously in money that you're going to have to fork out each month to run it, but also in terms of generating carbon that we're putting into the atmosphere that we're trying to avoid. Whereas this is taking carbon out of the atmosphere and providing shade. So I can't shout loud enough the value of trees. So what is embodied energy? Embodied energy is the amount of energy it takes to create an object or material and get it to the location where it is to be used. So that material, to make it, aluminium or something, a stone, it's got to be mined, quarried, extracted out of the earth. There's some manufacturing process to turn it into that product. There's probably some packaging that goes on around it. Then it's then put on a truck or a train or shipped across the Atlantic to Barbados, then picked up at the port, put on a truck, and then delivered to site, and then put into its final purpose. There's a lot of energy is going in to get it there, to make it, and to get it there before we even use it. And that's what embodied energy is. So these graphs here show a little bit of comparable between some different materials. So you can see at this upper end here, the lower, the better products which have less embodied energy. You're talking about mostly timber, plywood, those type of things. As you start to get down to glass, you're starting to kind of creep up something that uses a bit more energy, while steel, PVC, plastics, aluminium is probably the worst offender. And similar thing on this chart here. Cement is interestingly somewhere, in situ concrete is somewhere here in the middle of the chart or close up here. And I think, concrete blocks for Barbados could be quite a good solution. They are made here. Obviously, we do import the cement. But in terms of, something which is made locally and used locally, that's not a bad option. So yeah, where do your materials come from? Those are questions that we should be asking and weighing up when we decide, what materials we're going to be using. Things like bamboo flooring are a good solution because bamboo grows really quickly. So that's a very renewable resource. Composite decking and things like that use a lot of recycled content in the material. EnviroShake, I know that they use a lot of recycled content in their material, their product. But also locally, we have Duratile, which is the roof shake that's made from the recycled PET bottles. So that's great. That's made locally and it's using recycled content. So that's something that we should probably be looking at a lot more. Other green aspects, other than kind of, in terms of sustainable materials, just to touch on quickly, paints, we use a lot of paints. If we can use the low VOC, these are going to be much more healthy and more environmentally friendly as well. So historic solutions and current problems. On the left, this slide here is showing the traditional chattel house. It's doing a lot of good things in terms of green design. I mean, the main frame and structure and cladding is made from timber, whether it's this timber boarding or it looks like shingles on the side here. It uses some hoods to shade the windows. There's shutters. All of these are sort of shading devices, which kind of can limit the amount of heat gain, solar gain entering through the windows. The front door here, you can see this will be a jealousy type door that has louvers in it. That's going to allow the ventilation through the space. This high level vent up here is going to allow any hot air building up in the house to ventilate and escape up here. So it's using sustainable materials in terms of timber, and it's using a number of devices here which deal with our climate. By comparison, we see a lot of these, and these are quite popular now. The middle slide here showing these precast houses. And the issue I have with these are that I'm not completely against precast concrete because it's got a lot of benefits and it can be quite efficient in certain instances. But in this situation where we're using precast concrete for walls, the challenge is that there's no overhanging eaves here. There's nothing to shade these walls from the direct sunlight and heat, therefore by extension heat gain, because these walls are going to be exposed to the sun and soaking up that heat. And being solid concrete, they're going to be storing that heat and re-radiating it later in the day, maybe even into the night, 7, 8 o'clock at night. If you felt these walls, you know, you're still going to feel the heat coming out of them. That's one issue. The design has no provision for shading of the windows. So any sunlight coming on this side is going to be shining straight into the building. So you're going to have that extra problem of heat inside of the building. By comparison, the front door has not got any louvers in it. So there's no provision made to you know, I mean, yes, you can make the argument, maybe you need to open the front door and get the ventilation. That would definitely help. And then again, this slide here is showing the problem I alluded to earlier with people loving to pave all of our yards in concrete and hard surfaces. And I explained the problem with that. There's no planting here. There's nothing to break up the sun from hitting and radiating onto these walls and storing and generating all of this heat. So those are some of the challenges which we used to deal with. You know, you can see this has got lots of planting around the outside here. This might, and this could have planting here to help with shading and cooling. This one is not, unfortunately. So quick, if I got some time, quick case study. This is a house we did up in Long Beach called Red. Finished it about 2 or 3 years ago, I think. In this instance, this is the western side, and there's very little opening windows on this side. We kind of turned our back on the afternoon sun here, and really kind of opened up the eastern side, which is this side, to maximize ventilation. We've also used the building form here, kind of creating this stepping around, wrapping around patio to afford shading of this elevation, and also maximizing the operable windows on this eastern side to get the breeze in. Now, I did say there's not as many windows on this side, but they are at the back. I'll show you in the plan in a section, and there's plenty of space that the breeze coming in here can get back out as well. But we're thinking about planting, landscaping, shading. I mean, this was a new greenfield site, so all the planting here was new, but it was then. So it will take a little time to mature. There were no existing trees on this site, unfortunately. But looking at the site plan, north is to the left, so the breeze is coming from this direction. So we have a very long plan shape this way, so that all of the rooms on this site can get good access to the breeze. But already you can see that we're thinking in this plan, which was done by Kevin Talma, in terms of landscape. We're looking at planting, trees, shading. There's very little hard standing, pretty much only really where needed at the front here to get into the garage and some walkways around the building. The ground floor plan, again, breeze is coming from this direction. So this bedroom at the back, we've got an open plan, living, dining, kitchen here, patio, garage here. So in terms of thinking about orientation, one of the first things would be to stick this garage to the west somewhere. Ventilation for this is not a priority. It's not really a habitable space, and you don't want it somewhere on the east where it's going to be blocking breeze to the other spaces. This living, dining, kitchen space has floor-to-ceiling windows all along the east, louver windows so you can maximize ventilation. This kitchen door here has louvers in it, so again you can get breeze through. There's windows here, windows through the laundry, right through here. The first floor plan, all of the bedrooms are orientated with windows and doors facing the east, so you can get breeze through the building to maximize. There's no air conditioning in this house at all. We did make provision for in the future that if they did sell it or if they did change their mind, they could come and easily install the air conditioning, but that's 2 or 3 years and they haven't done that as yet. So this space is a wraparound patio on 3 sides here, again using the building form and shape to provide shade into the main structure. This is where I'm talking about a typical bedroom. On the eastern side, we have these 2 banks of louver windows, and then there's a glass sliding door. This can slide back in front of these louver windows, so you can have this whole thing open. What you're seeing behind this is a sliding louver shutter, which doubles up or triples up as hurricane protection, rain protection, sun protection. As you'll see, there's no actual curtains in this space. Privacy. So that screen can slide completely out of the way to allow you to get on the patio. So it's doing a number of things. And again, in these photos here, you can see in the bathrooms, in the kitchen, the living space, your very open plan, lots of windows, louvers. In this instance, we've used a lot of these aluminium louvers. So again, you can shut them down and they are secure in a hurricane. I'll leave you one last tidbit. So humans are only one factor in the ecosystem, but quite often we don't see it this way. We kind of see ourselves apart and we call other factors or species as natural resources or simply nature. So everybody's captivated about trying to protect nature. But once we accept that we're part of the ecosystem, the objective of sustainable design then becomes, how do we have a beneficial, positive input to the ecosystem rather than a negative input? And rather than how do we prevent the ecosystem from being influenced by humans? So we need to think about our input or input into the ecosystem being positive rather than being negative. Thank you, and that's it for me. I will leave you this one little comment here from Colin Hudson, who some of you older people may know. He was a Barbadian-born environmentalist and innovative scientist, and I remember him always saying to me, design green because it's the intelligent thing to do, not because it's the latest fashion, but it's actually the smartest thing that makes the most sense. Thank you.
Thank you, Neil. Thank you very much indeed. Thank you for pointing out particularly that we used to do these things properly in the past, and also for pointing out that so many of the solutions that we ought to be using now are actually quite simple solutions. And I think that's something which needs to be broadcast far and wide. Having said that, I'm not going to hold up proceedings any further, but I'd like to pass over to Asli, who's starting off the Argo presentation, and I think she will then add on straight away to Gavin.
Thank you. Hello, everyone. I'm Aslı, and today I will be presenting you case studies from Argo, eco-conscious housing for a sustainable future. And thank you once again for extending an invitation to Argo Development Studio to the Decarbonizing Barbados webinar. As I said, I'm Aslı, and I'm leading the Climate Intelligence Unit in Argo. Today here, together with my colleague Gavin, who is the studio leader for Caribbean projects, we will present you, and we will introduce you Argo's Climate Intelligence Unit, and then we will present you some of our case studies that demonstrate our commitment to sustainable design and construction. The first part is related with our Climate Intelligence Unit. I will do a small introduction to you. And as we all know, the architecture, engineering, and construction industry accounts for 39% of global carbon emissions. But at Argo, we collaborate with our clients to combat climate change and drive the shift towards a net zero future. Our sustainable project approach consists of location and climate analysis, scientific data collection, energy modeling, and then exploration of multiple solutions to identify the most optimal one. Argo's digital design and construction process allows us to intelligently analyze building performance in a virtual environment, resulting in the creation of environmentally friendly, resilient, cost-effective, and net zero energy buildings. Our team also focuses on designing LEED certified homes that promote clean indoor air, natural light, and the use of safe building materials, environmental friendly materials, to ensure optimal comfort and good health for the occupants. LEED is the world's leading green building project and performance management system. It's a globally recognized symbol of sustainability achievement and leadership. And LEED certification offers significant benefits, including, as I mentioned previously, improved health conditions for the occupants, substantial energy and water savings up to 60%, and increased property value with faster sales. Now I will move on to case studies. I will introduce one of our case studies to you, and then my colleague Gavin will continue to explain you. Our first case study is Apes Hill Villas. We used here BIM technology, building information modeling. It's a cutting edge and integrated methodology assisted the system built approach that provides increased passive ventilation with climate adapted shading strategies. And here we also use electric vehicle level 2 charging. It was designed to be in the villa carports. And here the roof is covered with reflective roof membrane, which is environmentally responsible, energy saving, and waterproofing solution with the highest solar reflectance index listed in the Cool Roofs Rating Council with 115, and also PV panels with 505 watt and 21% module efficiency were designed to be located at the roof level to produce more energy than what the building consumes actually. The estimated energy output per kilowatt per day, which is based on normal weather conditions, is 4.2 kilowatt hour. Sorry. And the wall consists of Gyprock wallboard, which is a fire resistant and acoustically insulated plasterboard. Rock wool insulation is applied to the outdoor facades with a recycled content between 16 to 40%. And the vapor control barrier, the vapor control layer ensures the air tightness and prevents condensation. It's effectively separating the passively ventilated area from the mechanically ventilated areas. And for the windows and doors, we designed to use laminated glass with a gray tint, which will provide light control and safety. The Chico door systems offer high thermal insulation, energy efficiency, and soundproofing properties. And they promote also comfort and sustainability while minimizing the energy consumption. Now my colleague will share and present you. Thank you.
Right, good afternoon, everyone. And thank you to the Town Planning Society for having us here. Thank you to Neil for a wonderful presentation and to Ashley as well. So I will continue from here. Now, the first project that I'd like to present is Clearwater Villa. With this project, we were looking at reimagining an existing property. And so our design and climate intelligence team took this existing property in Gibbs St. Peter. And what we sought to do was to design a luxury villa consisting of 9,727 square feet with stunning views of the beach. Now, this villa has a wide range of modern amenities, such as a gourmet kitchen, private gym, office space, 3 bedrooms with terrace space, and 1 master bedroom with a sunset terrace, including a private pool. To capture the energy efficiency, some of the things that we've implemented, we have extended cantilevered roofs and sheltered spaces, along with operable vertical shading elements that were designed by our radiation and daylight analysis to control the solar gain and create a better guest experience. Yeah, energy efficient homes reduce greenhouse gas emissions and combat climate change. Additionally, lower energy consumptions lead to reduced utility bills and low costs and low long-term cost savings. Now, what we have here is a simple diagram showing our passive strategies. So in the upper left-hand corner, you can see where the climate intelligence team took the model and ran it through their analysis to look at the average temperatures over the course of the year. And using this model, we were able to then orient the building to heat the pool, but to keep the rest of the building cool. We looked at setting up the building in such a way that we can maximize the natural ventilation, implementing electric vehicle charging station towards the front of the property, which is on our northeastern side. We've kept well-shaded windows that orient towards the prevailing breezes. We've kept our roof a light color with albedo materials, which help cool down the surfaces. We've implemented ceiling fans and a high-efficiency air conditioner to additionally cool the space. Towards the west, which has our views towards the ocean, we have operable vertical shading walls to increase the indoor and outdoor comfort. As we go towards the outdoor porch area, we have shaded porches and patios with overhangs that protect the indoor and outdoor from high-level sun rays. And then we have a water management system for pool, backwash, rainwater, wastewater, and black water. And where there were existing plants, we tried to retain as much of that in the native landscaping to reduce the heat generally produced. I'll go into more detail because with this project, what we sought to do was look at 2 options. The first of which was doing Clearwater and presenting it as a villa. The second of which we presented it as a condo option. And with the Clearwater condos, our design and climate intelligence team now sought to take the same property and develop it instead as high-end condos consisting of 27,113 square feet, again on Gibbs Beach. This offer has 3 types of condos with different layouts. 1 penthouse with 5 bedrooms. It has a family room and office space, and the condos are designed to be one of the finest properties in Barbados. But we're trying to do it, as we said, in a very energy efficient way. So taking a look at our passive strategies again, you can see how we've utilized the very similar systems to what we described on Clearwater Villas, where we're taking into account the passage of the sun, our wind direction to allow for natural cooling, and shaded porches, water management, and essentially this is how we approach our passive design strategies. And when we look at passive design strategies, there's steps that we go through. So we start to look at the orientation and building form. We look at shadings and overhangs. We look at natural ventilation. We look at natural daylighting, and essentially a passive solar design. So with respect to the orientation and building form, we look at the fact that proper building orientation can optimize natural light and heat gain. So positioning the windows to capture daylight and solar heat during the colder months while minimizing direct sunlight during the summer, and using the building forms to design to enhance natural ventilation and airflow. With respect to the shadings and overhangs, we strategically place shading devices such as roof overhangs and awnings, or louvers in some cases, to help block direct sunlight and reduce solar heat gain, particularly on the windows and glazed surfaces. This reduces the need for excessive cooling and helps maintain a comfortable indoor environment. With natural ventilation, we incorporate operable windows, vents, and openings to facilitate cross ventilation and allow for passive exchange of fresh air, reducing the reliance of mechanical ventilation systems. This approach enhances air quality and thermal comfort. Then from the point of view of thermal mass, using materials with high thermal mass, such as insulated walls, help absorb and store heat energy, helping to regulate indoor temperature fluctuations. And this also acts as a buffer, absorbing excess heat during the day and releasing it when the temperature drops. Now, designing the spaces to maximize the use of natural light reduces the need for artificial lighting. And this can be achieved by incorporating skylights, light shelves, or tubes to distribute daylight deeper into the interior spaces and maximizing energy consumption. These passive strategies, when combined with other energy efficient features, contribute to creating sustainable buildings that have reduced energy demands and an enhanced occupant comfort and lower the environmental impact. One of the other things that we looked at with the project, given that it was a reimagined project, is waste management. Now, construction waste management focuses on reducing, reusing, and recycling waste generated during construction projects. So by implementing waste management plans that include sorting and separating different types of waste materials on site, we encourage the use of materials by salvaging and repurposing the waste. So the buildings that are on the property, when we looked at this, as much as we would like to redesign them, they're currently inefficient in the use of their space. They have low energy levels and do not have the hurricane ratings that are critical for the Caribbean. So what we sought to do was to reduce the demand for new resources by reutilizing some of the existing materials. This aids in cutting costs related to the production and transportation of new materials and eliminates the need to send waste to the landfill sites. Now, in some instances, you realize that some of the materials that were used previously weren't environmentally friendly. We noticed that the roof contained asbestos, so we had to carefully look at the disposal of the materials. But in so doing, we were able to cite metals from the reinforced steel, structural steel, some of the steel roofing, pipe work, some of the existing electrical, plumbing fixtures, and window security bars that we hope to reuse. Concrete from the building structure that can be broken down and recycled as a base course in the driveways, footpaths, landscaping, and skid stairs. Timber from the veranda, roof panels, louvers, windows, fencing, doors, and paneling. You get the idea. Terracotta tiles from the flooring were all things that we sought to reuse into the project. One of the other things that we've done with the project is look into wastewater management and the energy and ventilation strategies. So as you can see in the diagrams here, we're looking at the construction of a double sanitary water supply system. So cold sanitary drinking water will be derived from the municipal aqueduct, and the network will be serving non-potable utilities. So that's the flushing of the WC cisterns, and irrigation from rainwater will be supplemented by the potable network. We're using our solar panels, which are feeding into the electric supply to help power the boiler, to heat the water that's going to be used. And we still have our rainwater collection that will be going towards our landscape irrigation and the flushing of the toilets. Separate networks will be created for the treatment of gray water and rainwater that will end up with landscape irrigation and the WC flushing. Whereas on the energy and ventilation side, we're capturing the energy on our solar panels to generate electricity that's feeding into the smart home. And the proposal is that we will develop a smart home system. The roof area and the facade are well exposed to the south, which is ideal for locating the PV panels that we have. And the ventilation strategy has been studied with the following objectives: to create a high level of environmental comfort while also having low energy consumption. When we talk about water management, we're referring to the responsible use, conservation, and protection of water resources. And in the face of a growing population and climate change, as a company, we believe it's critical that we incorporate efficient and sustainable water management strategies in all of our architectural designs. And one of the first steps that we can take is promoting water conservation by encouraging individuals and businesses alike to adopt water efficient practices such as installing water efficient fixtures, low flow toilets, faucets, and shower heads. We also believe in rainwater harvesting. One of the fundamental approaches to water management is sustainable architecture, is the rainwater harvesting. And by collecting the rainwater from roofs and other surfaces, we can store it for later use. This reduces the burden of fresh water sources and helps recharge the groundwater. This water, as I mentioned, can be used for irrigation, toilet flushing, and even potable purposes after proper treatment. We talked about gray water recycling. This refers to gently used water from bathroom sinks, showers, and the laundry. Instead of discarding it, we promote the recycling of gray water. So we establish systems that can treat and filter the gray water, making it suitable for non-potable purposes like landscape irrigation. And this strategy reduces the demand for fresh water and minimizes the strain on our wastewater treatment. The next case study that I would like to present is a housing prototype that we're doing in conjunction with the IDB. And essentially with this, we developed a prototype of low-cost, self-sufficient, and climate-resilient housing units that will provide residents with a central community hub containing the necessary amenities. So from the diagram, you can see that we've produced three model types: a 321 bedroom house, a 480 square foot 2-bedroom house, and a 640 square foot 3-bedroom house. And one of the main focuses while we were working on this project was to develop a plan that has flexible expansion that was achieved through a modular approach for effective compact living units. This approach allowed the use of shipping containers as the structure of the housing units, with the advantage of repurposing them, recycling them essentially after their life cycle ends, and reducing the carbon footprint with the goal to become more eco-conscious. With the IDB project, one of the things that we were considering was obviously earthquake resistance. Now, compared to the other islands, we know that Barbados has a relatively low magnitude earthquakes with a 10% chance of being potentially damaging. But shipping containers, when constructed as load-bearing structures with steel and reinforced by corrugated wall panels, achieve rigidity through corner anchoring, stacking, and steel connectors securing them to the foundation. So due to Barbados's vulnerability to storms and hurricanes, shipping containers offer a reliable solution as they're exceptionally durable, virtually hurricane-proof, and capable of withstanding the elements. Components of these containers work in harmony to enhance security against wind forces, forming a rigid structure with a roof system designed to include overhang limitations and hurricane straps. The expansion modules are created by the layout of Cargotecture. Based on the study of vernacular construction and the culture of Barbados, the proposed housing units are rectangular in shape, oriented to the wind directions for passive and cross ventilation, They have high louvered transoms to allow for heat dissipation through stack ventilation, and pitched roofs and covered outdoor patios with planters and vegetation as additional options. Now, if you take a look at the diagram in the bottom right, this was prepared by our climate intelligence unit. And essentially what they did was they took our 3D model of the 3 housing types and ran it through a temperature analysis to look at what the temperature in the building would be before the orientation, shading elements, and the vegetation was considered, as opposed to afterwards when we factored in the orientation, factored in some landscaping and shading elements. So just by taking those measures, we were able to significantly reduce the overall heat of the building. As mentioned, the building shape, the openings and the orientation, along with the interior layout, was designed to maximize natural ventilation. So as often as possible, we were orienting the buildings to maximize the prevailing breeze and keep the rest of the unit cool. And then our solar panels were positioned to face south with an angle between 15 and 25%. We utilized a solar hot water system that was designed to be received by the same PV panels. And we experimented with different panel efficiencies to take a look at the various payback periods and energy production. So in the bottom right-hand corner, you can see where we started to explore what would be the results of using different panels of different costs. So we used the same panel area, but with our first simulation, we were able to realize 8.9 kilowatt hours a year, resulting in $2,517 in energy savings, potentially a 5 to 8 year payback period. Whereas with our third simulation, we were able to realize 11.4 kilowatt hours a year, a savings of 3,209, and looking at potentially a 7.6 year payback. But those more efficient panels were, more expensive, which presents a slight barrier. With that, we also took a look at our water management strategies. Rainwater will be collected from the various roofs and stored in fiberglass tanks for the standalone prototype, and undergoing treatment in a designated 2 foot by 2 foot area with a pre-filter pump, UV and carbon filtration. And this approach enables off-grid functionality with separate containers for collection and storage, allowing the clean water to be pumped back for use. Gray water from the showers, laundry, and the faucet will be collected in a tank, treated and reused for plant watering and external landscaping. Irrigation in the standalone prototype, enabling off-grid functionality. And in the full community concept, gray water will be centrally treated alongside the sewage. In our standalone prototype, toilet and kitchen scraps will be collected and sent to an external composting system, generating biogas for cooking and fertilizer for the plants. And this off-grid approach is specific to the prototype. All wastewater will be treated in a centralized facility, while food scraps will be utilized in the community biogas system and landscaping fertilization. And this was important for us. Sustainable architecture emphasizes efficient waste management strategies. And so by promoting the reduction, reuse, and recycling materials throughout the building life cycle and incorporating this waste sorting within the building and the composting systems for organic waste, we're hoping to divert additional waste from the landfills and produce nutrient-rich compost for landscaping purposes. Now, in terms of the overall design and the community that we're looking to produce, we've looked at doing parking with solar roof structures that were designed to utilize electric charging of the electric cars, provide energy to the community. The arrangement of the houses in the public areas is designed to facilitate tertiary services at the ground level. We have green spaces and parks that offer areas for residents to enjoy and exercise using our outdoor activities. We're looking at the implementation of edible fruit trees as an asset for the community and visitors. And we're also looking at hydroponic farming that allows dwellers to benefit from the local planting and people, and especially young children, can learn sustainable practices and teach others. So this brings us to the end of our presentation. And in conclusion, we think that embracing sustainable and energy efficient architecture is not just an environmental imperative, but it's also a smart investment for a brighter future. And by prioritizing these principles, we can create buildings that harmoniously coexist with nature, minimize our carbon footprint, and inspire a sustainable legacy for generations to come. So thank you once again for being a part of our presentation, and I'll turn it back over to you.
Thank you. Thank you. I'd like to thank you both from Argo for giving us an illustration of how you can use the climate intelligence unit's work and a very scientific approach to work on projects both at the high end of the income scale and at the lower end of the income scale. I'm also impressed by the way that you build in flexibility and longevity to the projects that come out. Having finished the presentations, we can move on to the questions. I've got a few that have come in early, and then we'll be picking up others from the chat. The first question really goes to all three of the presenters. What they've been talking about is something which is very impressive and understandable to professionals and very interesting to the professionals, and they can see the advantage of it. But I'm wondering how the clients are reacting to the proposals for the green elements in schemes put forward. Now, are some of them more skeptical than others? Do some of them prefer to focus on short-term cost savings against what are long-term investments with longer paybacks, but which would benefit for a long time? I'm really asking you, how do you deal with your clients on these type of things?
Well, I'll jump in.
Gavin, go ahead.
You're going to go, Gavin. I mean, I think things like solar water heaters and PV panels are really becoming mainstream in terms of clients. So I would say most of the buildings that we're designing now, if we're not putting PV panels or incorporating PV panels within the design, we're putting provisions for clients to do that in the very near future. So I think that's the easy sell. PV panels, I mean, solar water heaters are kind of standard. You know, almost everybody thinks, you know, that's the standard go-to. So those are I think, in some ways the easy sell. But yeah, some of the others are a little bit more difficult. And clients are, yeah, weighing up the cost benefit, short, long term. I mean, that's what I'm seeing from my end. I mean, you know, we were mandated to put in water tanks by town planning, and a lot of people were not using them. I mean, all of the projects that we did, we would install pumps in and ensure that water is used, whether it's for flushing toilets or other secondary uses, washing the car, watering the garden, whatever. So there are some aspects which are easier sell, and some other ones which are not as easy to sell. That's what I would say.
And I'll echo a lot of Neil's sentiments there. Essentially, it's something that's very important to us. So on the majority of our projects, when we sit down, as Ashley mentioned, we have a process that we go through. So in discussing the design, we stress the importance of it, and our system allows us to do preliminary calculations to give our clients a sense of the budget, so that it's something that's not seen as an afterthought, but one of the earlier considerations when doing the project, so that it can be factored into the overall budget. And more and more, we're trying to make it part and parcel of what we do. We do appreciate that there are some barriers to entry that, you know, as time progresses, become a bit more accessible. But by and large, this is something that we promote on every project that we're involved in, whether it be a lower end residential or a higher end commercial, because again, we think it's critical.
And I mean, when you start to think about, I got some friends that I would chat with, and we would discuss what our electricity bills are. I don't have any air conditioning here at home. I had put in a 2 kilowatt photovoltaic system, I don't know, maybe about 8 years ago. And when I did that at that time, that was covering my bill. But it isn't now. My bill has now gone back up to like maybe $125 a month. But people are probably going to be like, what, $125 a month? That's all? People are spending $500, $600, $700 in electrical, in their electricity bill a month. And a lot of that is down to air conditioning. I mean, I have also changed out all of my bulbs in my house to almost all, I think, to LED. So I think once you start with those things, so there are two aspects: is the existing housing stock, and then there's a new housing stock. The new housing stock, we could, in an ideal world, we could design great, but there's loads of things that the existing housing stock that we can do to reduce our carbon footprint and the ecological footprint. Simple things like changing your light bulbs, which I think a lot of people know about now. But a lot of what I was saying there in terms of planting, landscaping, how is the there are relatively cheap options. Okay, you might have to wait a while for a tree to grow, but there's some fast growing trees and shrubs, so those are things which, existing buildings you could tackle to provide shading, cooling in the immediate area. Yes, if your building is not designed to maximize natural ventilation, well, then you're going to struggle with the existing building unless you go and do some sort of retrofitting. So in that instance, if you're adamant that you're gonna, you can't bear the heat and you have an air conditioning unit, or you want to put in an air conditioning unit, you need to start to look and say, well, you probably need to lean towards the inverter technology, which is using less energy. And ask those type of questions. Is this air conditioning unit that you're selling me, is it an inverter air conditioning unit? How much energy is it going to use or save me? Those type of questions. But yeah, I mean, you build 9.5 times out of 10, we're going to start with looking to how can these spaces be orientated to maximize natural ventilation for these spaces, and then only and even where we have expat clients, where most of them are still asking for, they recognize that it's healthier to live, it's better to live in an environment where you're not breathing that recirculated air, because unless it's done properly, there can be issues there as well in terms of how healthy that is for you. So, and people do want to be in the outdoors, but they want to be in the outdoors in a comfortable, cool environment. So, as I said, even the expat clients we have, quite typically, it may just be the bedrooms, which, they could retreat to get an air conditioned environment.
Gavin, you want to say anything else?
No, I think we've covered most on that particular question and on that topic. But yeah, no, I agree with Neil. And when we have our discussions with our clients and we take a look at the site and the topography, and we start to think about building orientation, those are the considerations that we're making first. As I described with the high-end homes, that's where we're looking at mechanical ventilation, but that's not the first route that we go. As often as we can and as best as we can, natural ventilation is the route that we try. Go ahead, Ashley.
No, because you were explaining the process, I think I just wanted to share it one more time to show it while you were explaining, like how we start with all of our projects. Like we meet with the client and we understand their needs, the project, the scope, the budget, with the design resilience as also it's our additional focus. And then we move to the second part, which is to gain an understanding of the location and its climate. We are collecting scientific data and we are doing research to understand passive strategies in the based on that location. Then we are moving to the modeling part, and here we begin with the BIM process by energy modeling to understand the elements such as carbon footprint, energy efficiency, solar radiation, and we also use, like, for example, for this energy modeling process, we use Revit, but also we have additional softwares to do the simulations. And then we continue with the development step that where we develop multiple approaches, selecting from the breadth of the latest sustainable design and construction in order to arrive at most optimal solution for the specific projects. And we are also allowing for flexibility and safeguarding the budget. So after that, we move to the benchmark part step, and we compare real world scenarios by using our sustainable tools and calculations that incorporate climate-based benefits, energy efficiency, flexibility of design, and the budget again to exactly measure the benefit to both our clients and also for the climate. Then we remain fully engaged with the project right through the delivery to ensure our design process is honored by contractors and external parties to ensure the best possible execution of our solution. So as my colleague also said, as Gavin said, we start from the beginning. Really, we start from the beginning by implementing the importance of the climate intelligence to our clients. And since we are doing it step by step, it's also clear for them and they appreciate the results.
Great. Thank you. I've actually got two things in from the chat now, so I'd encourage more people to send in questions from the chat. The first thing in wasn't a question, though. It says excellent presentations. So there's positive feedback for the three of you from that. The second question is from the NHC planner, and he wants to know, did the IDB project examine the cultural acceptance or implications of housing persons in containers in places like Barbados, as an example?
And I think that that's a fantastic question. You know, I think when you're introducing, and at this stage, I wouldn't say that container housing is necessarily a new thing. There are not as many examples of it in Barbados, but we did undergo some studies and we carried out some surveys and discussed it. But the quality of the finishes with these container homes, the insulation that we're using, the standard is as good as almost any of the other products that we're putting out, you know. So again, there are going to be barriers. I like the way that the question is posed, you know, the implications of housing persons in containers. Again, at face value, it is something that definitely needs to be considered. But if you see the quality of finishes that are being proposed and couple that then with the cost effectiveness, the environmental and other savings that can be had from it, I think is something that will be well received, and initially was very well received. I don't know if you'd like to engage in conversation on the topic, because there may be follow-on questions to that.
Thanks. I was just wondering if talking about these things with the public sector generally, is there an appetite for taking up some of the basic principles as well as the specifics around the container design, issues like natural ventilation and so on, which are things which can save people a lot of money to start with?
Well, I think that those are conversations that are being had and that need to continue. I think whenever there are different building methodologies being introduced, there's initially going to be some form of resistance unless people are properly educated and informed on what those systems are and how they're intended to be implemented. And so, like with any new system that's being introduced, all of the pros and cons need to be weighed, and people need to be properly informed, and there needs to be information shared on what the advantages are, so that it's not a system that is being taken for granted that will just be easily adopted. I think in general, people are open to new ideas and new systems, as long as the information that supports it makes sense to them, and in times like these is financially viable.
Kim,
Thanks.
could I throw that question back on you, or an angle of that question back on you a bit?
Yeah, please.
When we have these large housing developments, whether it's government or private sectors, quite often you might get a planner involved, and they may do a subdivision layout which figures out how you divide all the lots in this big development. And then somebody goes away and does some typical house type design and drops it on there. How much interaction on your end from a planner point of view is there? Because I think I see a disconnect. I think the architect or the designer doing those typical cookie cutter designs that are replicated needs to be intricately involved in that master planning process. Because if you're, I mean, there are different challenges. There's doing that subdivision for the optimum layout for ventilation. There's doing that layout for the optimum layout for cultural, social interaction between houses and how the houses relate to each other, and the space between the houses. So what, from a planner's point of view, what's your take on that sort of situation?
Well, thank you for the question, and again, the way that it was presented. Now, in this specific case, we were given the entire parcel of land that we then got to work with the planners in terms of how we wanted to have the buildings oriented and where we wanted to situate green spaces, how we wanted to have them interact to facilitate the ventilation, which is not the typical case when there's generally a large subdivision of, let's say, low to middle income homes, where I do believe in all instances some consideration is given to prevailing winds, sun direction, but essentially you're looking at the civil works that needs to take place, providing access, and as you said, utilizing the land as efficiently as possible to ensure that everyone is getting a decent size, not just unit, but a decent size lot. With that project, we were essentially given carte blanche to take the lot and say, well, how can we, because you're already working with a very modular design, but how can we do this and orient it in a creative way, in a way that aesthetically is at least somewhat inspiring and doesn't look like just a cookie cutter module. No, there is a lot of repetition. You know, if I just quickly share again what
But Gavin, sorry to cross you. That question was really directed at Kim as a planner, somebody sitting on the town planning, Barbados Town Planning Society. You know, I was kind of devil's advocate, kind of throwing that question earlier, because I think sometimes you may get a subdivision done, and then somebody comes along and figures out, you know, some sort of typical design which is dropped on there afterwards. By which time it's a bit too late. You may be just looking at how you're going to mirror and, you know, rotate some houses to try and kind of make the best of what you're given. Whereas, yes, in an ideal situation, you would have what you have here, where you are involved as a unit designer. You're involved from day one, and you have some say in terms of how that master plan works, and or not, in terms of you know, what's the best way to divide up, put the roads in, therefore allowing for fronts and backs of houses. You know, because just for example, if you have say you have a development road running north-south, then, you know, and the lots sort of to the east and the west of that road, then some houses may have the front sort of looking east, and some houses may have the front looking west, and need a very different design to deal with those in terms of natural ventilation.
Neil,
Absolutely.
thank you. Can I come back to you? It's Kim. I thought you were trying to get a planner response, because what I think is also significant is not just that we're talking about a subdivision where a public sector development is going on, but we have lots and lots of private sector subdivisions all over Barbados, where I think the actual orientation and climate relationship of the house that eventually gets built is probably the last thing that's thought about in putting together those subdivisions. They take account of an efficient road layout, perhaps. They take into account the water reticulation issues, so everybody gets their water. And they probably take into account issues about getting as many of the particular size plots that people are looking for from an economic point of view on that site as possible. But there's no question of master planning going into the way we divide up land into subdivisions. And I think it's an issue that we need to take into account. And I think maybe there's a need on subdivision applications for more pre-application discussion than there tends to be on them, because they're almost just a change of use with a drawing which comes along with it, and you worry about where the houses are going to be later. So I think I'm very much with you. I support a master planning approach for any major development.
I mean, and that sort of approach where you kind of just subdivide the land and then sell off the land, and somebody comes along to create their own design, well, then the designer can work with whatever condition they're given to create the best layout. But where you have a cookie cutter design that you're just kind of, you know, typically with a lot of low income government housing, or not only government, but other private developers doing the low income housing, where you've got 2 or 3 designs, and you know, you sort of mass produce these and drop these on the site. I think from what I'm seeing, I think there needs to be more thought going into how that master plan site layout is done to facilitate better, you know, because the same type A that works on this lot facing east is not going to work that great on the lot facing west necessarily.
I've got some feedback in from the chat, which is saying that one person saying this should be done on all projects. Somebody suggests I'm not being accurate, which is possibly true. And someone saying it's also because land surveyors do the subdivisions instead of planners who should do it. Now, I'm not interested in getting into a fight between professionals. I'm interested in getting into a professional solution that provides the best answers. And I think a bit more thought into how we go about doing these things early on would be very useful. I've not got another separate question on the chat, so I think probably the last question that I've got here is if we're getting down to if we're getting down to sort of developments of a number of houses, what would the key factors be to put into that equation when somebody's sitting down and starting to consider putting together a site that's going to have 20 properties on it, say?
I think it'd be what we were just talking about, to be honest. Yeah. I mean, yeah, how are you going to divide up that land that does make it easy for people to I keep coming back to natural ventilation. That's because this air conditioning is one of the biggest in terms of carbon footprint, in terms of decarbonization. Air conditioning and housing is one of the biggest energy users in housing in Barbados, in the Caribbean. So I think the way you can, I mean, unless they're you know, existing wooded areas, forest, planted area, trees on the site that come into some design in terms of how you can utilize that. I think, yeah, I think a big part has to be how do you look at dividing up that land, that makes it fair or to the benefit of everyone to maximize their natural ventilation.
Key issue. Gavin, is there anything you'd like to come back to on that, or Ashley?
For example, for the natural ventilation, what I can say is there are also simulations and there are regulations to check the distances between the houses, check the building depth and building width. So according to that, you can put your locate your windows or your openings. And also for the daylight, you need to do these kind of checks, not just for natural ventilation in the end. So yes, when you are planning the whole parcel, let's say, it should be depending on the dimensions and distances between the let's say the masses around and the surroundings. And some of them can be you can get some of them from some regulations, and some of them by the softwares you can control them by because it's kind of, you just need to move around the masses and you will see how the air is moving inside or around the buildings and how your openings are affecting interior of the houses.
Right. Okay,
But
thank you.
To touch on that subject though, the question, are you making a pre-assumption, or are you assuming that the most environmentally friendly green way of doing housing for Barbadians is individual lots with individual houses? Or because you could enter the discussion, maybe we should be looking at more high-rise housing more of our people in high rises, which are denser. There are challenges with ventilation with that too, but are denser, that allow us to use a smaller footprint to house our people instead of this urban sprawl with new developments in every turn of the corner, using agricultural land that we could be using to grow food on, to be more sustainable. So that's a question, you know, I think.
Yeah. For example, what we did in IDB project, we didn't go so much high rise, because also we cannot just put high rise really huge building in Barbados. It's also related with the cultural senses, vernacular architecture. It should not look like you just bring the building there, even it has a small footprint, and you may save from the carbon footprint because of the size of the building, because you are going up, not you are not spreading around on the side. But this should be checked with the culture of the Barbados and also the vertical architecture techniques, I think. So we should find a balance somehow in between all of them, because yeah.
Okay, thank you. I think I'm looking at a watch and we're running over time at the moment. There are a few points coming in on the chat, which I think people can have a look at individually. But what I've warned all the speakers for beforehand is that we like to finish off these sessions with asking each of them to provide a 1 or 2 minute message that they would like people to go away from the session with, if they remember nothing else. And that's the last part of it before I thank everyone for attending. So which of the speakers wants to start? Go on, Neil.
I can start. I'd forgotten that you mentioned this, Kim, but I think you know, sometimes you can be overwhelmed by all of this information, and I think you just need to make a start. All of us just needs to make a start. Go and change the light bulbs in your house, plant some more plants around your house, and you know, then start to worry about the more complex issues after that.
Okay, thank you. And which of the two of you from Argo wants to go first?
I can go if you want, Kevin.
Yes, please.
Please feel free, Ashley.
Yeah, okay. Oh, sorry, just a second, my headphones. Okay. What I can say also related with the yesterday's, like, let's say, recent hurricane impact in St. Vincent and the other islands. The recent hurricane impact in St. Vincent highlights the urgent need for sustainable housing solutions or sustainable building solutions. that can withstand the extreme weather events and promote resilience. By prioritizing altogether sustainable building practices and incorporating resilient design features, we can create a safer, more environmental friendly homes for communities and for everyone. Thank you.
Gavin?
Thank you. Yeah, no, and I would just say, you know, we're blessed with a beautiful island, but we don't have a tremendous land mass. So, you know, there's not a lot of time to continue to get this wrong. We really have to look at preserving what we have and thinking about developing in a sensible way. And we have enough people with experience in different areas that we can do this effectively. And it's good when all those parties come together for the common good. And so opportunities and forums like this are good to share information and just see the parties come together, because we all have our shared interests at heart when it comes to sustainable development. And it's necessary for future generations.
Thank you, Gavin. I think that summed it up brilliantly. So thank you very much indeed. I'm going to finish now by thanking all three of you speakers for your contributions, all of which were extremely relevant and gave us a lot to think about. And thank you for responding to the questions. I will thank the attendees as well for their questions. I might have wished that more questions had come through quicker on the chat, but that's something I might encourage people with next time. There are things on the chat which people can pick up and maybe take up between themselves. Finally, I'd like to thank the BTPS team for their support on this. Andy, Joy, and Georgina on the technical side, and Sandy for organizing the speakers. This has been, I hope, a very useful, stimulating session for everybody. We'll continue to hold webinars on relevant issues. And as I said, we will try to get back to the HOPE project again, and look at the aspects of that through maybe a site visit to one or more of their sites. So we'll get back to you on that later. Thank you, everyone, and have a good day. Thank you.
Thank you. Bye.
Thanks to everyone.
Thank you.
Thank you.
Bye.
You.